Hello everyone. In the last video, we have seen the symbolic representation of the queuing models, and we also saw the characteristics of queuing model 1 as well as queuing model 2. Okay, and we have gone through the several formulas and how to calculate those quantities. Now let us look at some problems based on the two models. A TV repairman finds that the time spent on his jobs has an exponential distribution with mean 30 minutes. Okay. So whatever service he is providing, the TV repairman, that service providing thing is having the exponential distribution. So Poisson distribution is sometimes also called as exponential distribution. Okay, so what does this sentence tells you? That the service which is provided, that follows the Poisson distribution. So you got one information, that is the second one, it should be the M. Okay, that means B, the value of B will be M, so it's the Poisson distribution. Then a distribution with the mean of 30 minutes. This we will see later. Then if he repairs on first come first serve basis, so what does this gives you? This gives you the value of E, so that will be first in first out. They are the same things, only the wordings are different. Okay, then if there is a TV repairman, only one repairman, so that gives you that value of C is equal to 1. And if the arrival of sets is Poisson with the average rate of 10 per 8 hours a day. Okay, so arrival of TV sets is Poisson, means what? The first A value is equal to M. Okay, then what is the repairman's expected idle time, and each day, and on average how many sets are there in the system. Okay, these are the two things that we will have to calculate. Okay, but see here, the above problem gave us the information that A is equal to M, B is equal to M, this C is equal to 1, and this is FIFO. Okay, and you see that there are no restrictions on how many TV sets can come there in the shop. Okay, so that tells us that this becomes infinity, and from here this representation you can clearly see that this problem comes under the model 1. Okay. So now we want to calculate these two quantities, but if you have observed, for calculating any characteristic, what we need is the value of lambda and the value of mu. So what does the lambda represent? So lambda represents the number of customers per unit time. So how many TV sets are coming per unit time? So here the unit will be, let us stick to the unit by taking it as a R. 1 hour will be the unit for time. Okay, so what information is given to us? Note that this is this model 1. Okay, it's this model 1. Then arrival of TV sets is Poisson with an average rate of 10 per 8 hours a day. Okay, now so 10 TV sets come per 8 hours. What we want? We want to calculate how many TV sets per hour. Okay, so if 10 comes for 8 hours, 10 by 8 sets will come for 1 hour. Okay, so this quantity is approximately equal to 1.25 sets per hour. Then what is mu? Mu is nothing but the service rate. That means the number of customers served per unit time. So unit of time is 1 hour. So what does this problem gives us the information? What it says about the service time? So it says that it has the job, his job has an exponential distribution with mean of 30 minutes. Okay, so one TV requires 30 minutes, one repairing requires 30 minutes. So to serve the one customer it takes 30 minutes. What do we want? We want to calculate how many customers served per hour. Okay, so what we will have to do? See here, 30 minutes per set. And what we want? We want how many sets per hour. Okay, so what does this tell you? This tells us that 30 minutes per set means 0.5 hours per set. Okay, and what we want to calculate? How many sets per hour? So that will be 1 divided by 0.5 sets per hour. Okay, but what is 1 divided by 0.5? That is nothing but 2. So it will be 2 sets per hour. Okay, then now we know what is lambda and what is mu. So now we can easily calculate what is rho. So what will be the value of rho? Rho will be lambda divided by mu. That answer comes out to be equal to this 0.625. Now what we want to calculate, what they have asked us to calculate, we want to calculate what is the repairman's expected idle time each day. So we want to calculate the repairman's idle time. Idle time, when will the time be idle for that repairman? When there is nothing to repair, when there are 0 customers. Okay, so what will be that? We will calculate, we have to calculate basically what is P naught. Okay, because what is Pn? It denotes the number of n arrivals in that particular time. And because we want to calculate the idle time, that means there are no arrivals, there is no TV. So in other words, there are no customers in the system. So that is what we want to calculate, P naught. So what will be P naught? Formula. The formula for P naught will be equal to, this is model 1. So probability that the repairman is idle will be P of this 0 customers in the system. So that is P naught. And because it is model 1, you can, if you refer to the previous video, you will note that, or the list of formulas, you can clearly see that P naught is calculated as 1 minus rho, and the rho value we already know, so hence we get this P naught. Okay, then there is a next thing, that is on an average how many sets are there in the system. Okay, so for this we will have to calculate what is, because we are talking about the system. Okay, so for that we will have to calculate what is E of n. Okay, capital E of n, and what is the average number of customers in the system. Okay, so if you refer to those formula list, you will observe that it is 5th characteristic for model 1. Now let us go for the next problem. In a supermarket, the average arrival rate of customers is 10 every 30 minutes following the Poisson process. Okay, so the arrival rate is the Poisson process. This tells us that first letter A is equal to M. Okay, so I didn't write it here, so the first one will be M. Then the average time taken by a cashier to list and calculate the customer purchase is 2.5 minutes following the exponential distribution. So this tells us that even the service distribution is Poisson. So second letter is also M, and there is only one person who is serving, so that is the cashier. So that C value is equal to 1. Okay, and then we have to calculate what is the probability that the queue length exceeds 6. Okay, so here you can see that there is no restriction on the number of customers, so it becomes infinity, and the discipline is first come first serve basis, so that is FIFO. So this problem comes under the model 1. Okay, now what we want to calculate, what is the probability that the queue length exceeds 6. But before we calculate this, first we will have to find out what is lambda and what is mu. So what is lambda? Lambda is the arrival rate, that means how many customers per minute. Okay, now here the unit of time will take it as minute, because everything is given in terms of minute C. Okay, so how many customers per minute, that is what we want to find out. So lambda is the arrival rate. So how many customers come per minute? Information given is 10 customers come every 30 minutes. Okay, so 10 customers come every 30 minutes. So 10 divided by 30 customers come per minute. So that is 1/3 customers per minute. Then what is the mu value? How many customers are served per minute? So mu is 2.5 minutes per customer. Okay, now see here, it is given that the customer purchase is 2.5 minutes following the exponential distribution. Okay, so 2.5 minutes for one customer. What we want it in this form: how many customers per minute. Okay, so if 2.5 for 2.5 minutes one customer, then 1 divided by 2.5 customers per minute. Okay, so these are the simple things to understand. You can easily calculate this. You can use that cross multiplication trick. Okay, you all use that, no? See, for 1 minute, if suppose there are, so for 1 minute if there are, sorry, for 2.5 minutes there are one customer, there is one customer. What we want to find out, for 1 minute how many customers. Okay, then you do that cross multiplication thing, so it will be 1, so it will be this into this divided by this into this, but this x remains outside. Okay, so this into this divided by this, so it will be 1 divided by 2.5 customers per minute. Okay, then that will give us the value of mu. Once we get mu, we know what is rho, so rho will be lambda by mu, and it comes out to be this. What we want to calculate, what is the probability that the queue length exceeds 6. So what do we want to calculate actually? We want to calculate probability that the number of customers in the system is greater than or equal to 6. So if you have noted down the formulas, you will observe that in that formula list it is the fourth characteristic under model 1, that is probability that number of customers in the system is greater than or equal to k. In our case, k is equal to 6. Okay, because we want to find out probability that the queue length exceeds 6. Okay, so greater than or equal to 6. So the formula will be rho raised to k, and that will be rho raised to 6. So it is this. Now let us look at one more example. In a railway marshalling yard, goods train arrive at a rate of 30 trains per day. Okay, assuming that the inter-arrival time follows an exponential distribution. Inter-arrival time is exponential. That means what? First letter A is M. Okay, A is equal to M. Then, and the service time distribution is also exponential. That means second is also M, with an average of 36 minutes, and calculate the following. Okay, so there you can see there is nothing restriction mentioned. So the D value is infinity, and it is first come first serve basis, and there is only one service provider, so it will be 1. So and it comes under the model 1. Okay, so now let us calculate what is lambda and mu. Lambda means what? How many trains? So lambda will be how many trains per minute. Okay, see here it is given in the second, it is given in 36 minutes, no, with an exponential distribution. The last line over here, it is given in 36 minutes. So let us consider the unit as minutes. Okay, now see, I am considering it as minute. Even if you want to consider it in as hour and solve the problem, that is also fine, no problem. Okay, provided you do the calculations correctly. Let us fix the unit as minutes, because here we have this given in minutes. I try to come to the smaller ones. Okay, if hour and minute is given, let us choose the minutes because it's the smaller unit, no. Then if day and hours is given, let us choose the hours. Okay, so here average of 36 minutes is given, so let us stick to the unit of time as minute. So how do we calculate lambda? Lambda is arrival rate, that is number of customers per unit time. So we want to find out how many customers per minute are coming. Okay, so information given is what here? Who is the customer? Customer means the trains. So 30 trains per day. So what does this tell us? It tells us that 30 trains per day means 30 trains per 24 hours. Okay, now that means 30 trains per 24 into 60 minutes, because 24 hours is how many minutes? 24 into 60, these many minutes. Okay, so 24 hours means how many minutes? 24 into 60 minutes. So it tells us that 30 trains per 24 into 60, these many minutes. What we want? We want to find out how many trains per minute. So what it will be? If these many trains for these many minutes, for 1 minute how many trains? That will be this 30 divided by these many minutes. Okay, so 30 divided by 24 into 60 trains per minute, and that answer comes out to be equal to 1 divided by 48 trains per minute. What is the mu? Mu is the service time distribution is also exponential with an average of 36 minutes. So one train in 36 minutes. What we want to find out? How many trains in 1 minute? Okay, so that will be, see, one train in 36 minutes. We want to find out how many trains per minute in 1 minute. So it will be 1 divided by 30 trains per minute in 1 minute. Okay, so now we have the value of lambda, we have the value of mu, so we can calculate what is rho. And once we calculate rho, then what is that question is asked? The mean line length. Okay, so here we will have to calculate what is EM. That means average number of customers in the queue. Okay, so if you see in the formula list, you will observe that we want to calculate what is E of M, that is the sixth characteristic, okay, which is equal to rho square divided by 1 minus rho. Okay, and what is the next question? The next one is the probability that the queue size exceeds 10. So what will be this? The queue size exceeds 10 means we want to calculate the probability that the number of customers is in the system is greater than or equal to 10. So in the formula list, it will be, you can see clearly see that it will be the fourth characteristic, okay, in model 1. So that will be rho raised to 10. So that is what you want to calculate. So we'll stop here for these problems.